Right guys, let's have a look at this circuit diagram here. This is one I just quickly put together. We've got our DC power input, plus 5 volts, plus 12 volts in ground. Going to 2 indicator LEDs here, so we know the 5 volts is running and the 12 volts is running. A couple of decoupling capacitors for the microcontroller, a K-peg buzzer. Down here we're using a PIC18F4525 microcontroller, very reliable one. We have our 10 MHz resonator here, so this has internal and external clocking. Here we have our program port, which is for the integrated development environment, so we can do real-time coding or in-circuit coding and debugging. So this is basically TTL level serial input. We've got a TTL level screen output here and input. So when we want to add the display, we'll simply do it from here. Now this is the important part. This is the FET drivers for the solenoids. So you got the FET1 here and FET2 here, which will be driven by the microcontroller. We've got some pull down resistors to make sure we have no false triggering. We have some blocking diodes here to stop reverse current flow. And we have a 24 volt DC input here to power the 2 solenoids, one for inhalation and one for exhalation. Sorry, tongue's twisting at the moment. But so that's the basic circuit, and it looks something like this. And let's do a 3D visualization. So it's going to be something like this, very simple because it's early stages. It's just to begin the automation process. Let's have a look at the code. We're going to be using PIC Basic Pro, which is one of my favorite languages, interpreters. Here we've got some basic configuration switches for the microcontroller. We've got the port setting for the display. Here we got the port directions, whether they're inputs or outputs. Then we have an alias here. Buzzer is basically port B.7 in the code. FET1 is basically port D.1. FET2 is basically port D.2. So here I'm telling the buzzer and the 2 FETs to be in a low condition or an off state. I is just a variable, byte size variable. Here I'm telling the buzzer to buzz at a frequency of 115 for 500 milliseconds. Okay, here's the main program as a test. We're going to ask the microcontroller to pause for 2 seconds, because this is obviously in milliseconds here. We're going to turn the output high for FET2, so that's going to be on for 3 seconds, and then we're going to switch it off, and it's going to be off for 1 second. And then the exhalation side, which is FET2, we're going to make that solenoid high or on. We're going to pause for 4 seconds, so the program will switch that on for 4 seconds, and then we're going to go low for 2 seconds. So we keep some peep in there, and then basically loops back to the beginning of the program. So when it loops back here, pause for another 2 seconds. So let's see if this works. let's have a look at this. Got my +5 +12 volt power supply. Going to our new PCB which we just built. This is the ID interface from my little serial to TTL converter there, which we can then program in real time for debugging purposes. We've got our two outputs for solenoid 1, solenoid 2. So if we go this way, exhalation solenoid, our makeshift lungs, our inhalation solenoid, little gauge, our pump, and our 24 volt power supply, bench power supply. So let's see if this thing works. Switch that on. Send 24 volts to the solenoids. Plug in the pump. As you can see, we have pressure. Right, I've already sent that demo program to this. So let's switch on. With the buzz. Oh, there goes the lungs. Happy birthday. Alright, let's change some of the timings here, and I'll show you. Right, sorry about the flickery screen. Okay, so let's say I want here to go for 4 seconds, 4 seconds out, and no pause to begin with, so we just go up here, file, compile and program. So now we change the timings. And this will happily work all day. Right, I think for now that's it. As usual, like, share, subscribe, do whatever you gotta do.